And so today I'm going to be talking about fireworks. So fireworks are pretty cool. They were invented around 1,000 years ago in China, where they invented gunpowder. It's pretty genius, but today I'm not going to be talking about the actual chemistry of it, which is what people mostly talk about. Instead, I'm going to be talking about the physics of it, which has a couple different components. So to begin with, the initial launch. So when you're actually, yanking that firework into the air, and that's mostly due to this thing called Charles's law, which basically dictates how things like cannons work. So what it is you have a container with a movable part, like a lid or whatever, and when the pressure inside that container changes, the lid will move, right, to alleviate that pressure. So in the case of cannons, which are how, that's how you launch a firework, is you put it inside a cannon. So, in the case of cannons, what you're doing is you have your gunpowder, or your explosive, and it has a chemical reaction, which sends not only the particles from the chemical reaction and the particles that made it up, but also it creates a lot of heat. So it sends those things flying and makes them really hot at the same time, which creates an enormous amount of pressure inside the container. And because it has that movable section, the entire thing doesn't explode, it just goes straight upwards because it's the easiest way for it to alleviate that pressure. And so there's an equal force up and down, but because of the normal force of the ground, the bottom doesn't move all that much. And depending on the length and diameter of the cannon, you're going to get a longer or shorter parabola or height. So here I'm just going to draw that parabola. So what's going on is you have that initial kinetic energy that you get from the cannon, and it zooms up and it gets a ton of gravitational energy, right? Because it goes pretty high. But at some point the kinetic energy all transfers into gravitational, as we've learned in class. And then because fireworks follow the laws of gravity, it goes back down, transfers back into kinetic energy, and hits the ground eventually, right? So with fireworks, because the fuses inside the actual firework that explodes, it's timed so that it will explode at the top of the parabola. So you only actually see half of the parabola. So it's not as if fireworks just, don't work like the rest of the world, and they're not an exception to the laws of physics. It's simply that they're timed to explode, and the bit that explodes, all of those little sections that go flying, they continue the parabola in and of themselves, but they do actually finish that. They do transfer from that gravitational energy back into kinetic. So when you look at the actual sort of rough anatomy of a firework, you have the little cap that makes it aerodynamic. You have the fuse. Inside it, you have a ton of explosive, which is your burst charge, and all these little metal balls, which are called stars. And they're what you actually see, right? They're the little glowy bits. So in the original firework, you would see another section below that, which would be another set of explosive, and that's the lift charge that we ignited and exploded at the very beginning, creates that first big boom that you hear. But because I'm drawing the firework at the stage where it's already in the air, we don't have that lift charge anymore because it blew up. But you do have this burst charge, which can be either simple or complex. If it's simple, everything's going to explode at the same time. If it's complex, then you could have it going in different stages. It could all be going in a certain direction. The people who make fireworks these days, they make them very complicated so that they look prettier and stuff. But basically, the burst charge explodes. And this is what you actually see, right? This is what people go to see. They go to see the explosion and hear the big noise. So that transfer of energy, so you have the heat from the fuse, which was a byproduct of the last explosion, and the chemical energy that is stored inside of the burst charge, as a byproduct, so it creates that kinetic energy that we're looking for, it creates that explosion, and it also creates a ton of heat, which actually heats those little balls up to about 1,000 degrees, which is really high. And sometimes, so when you see a firework and it explodes and then there are some bits that appear to go spinning, or they change direction for some reason or whatever, that's because each star in those cases is actually kind of its own little firework. So basically it has its own propulsion, which is some more gunpowder or whatever, and its own fuse that goes at the correct time and whatever. So assuming that, again, it's not a dud, it will explode and change direction or whatever, and it'll have its glow already. So the glow that I've been talking about, that light we all see. So going back to grade 10 physics, when you look at an atom, it has electrons, right? And electrons can have different energy levels. And when you add a ton of energy to an electron, it goes from its ground level energy, which is where it's happy, and it goes up to a high level of energy, but electrons don't like to be there, and so they'll try and go back down. So in this case, you're adding a ton of energy to the electrons by adding heat. And then it goes back down by removing that energy in the form of light, which is what we see, right? And so when you heat up a piece of metal, and so these stars are made of metals. When you heat up a piece of metal, it glows kind of reddish, right? So how do you get those fireworks that are different colors, right? Because, you go to a display and you see green ones and yellow ones, and occasionally you'll see a blue one and stuff. So how does that work? So back again to grade 10. We're just going on a little time trip backwards. Anyway. So you see, it's actually Roy G. Biv, but you see the rainbow and you see all these different colors, and as if you can remember, different chemicals have different spectral lines. So when you look at a chemical, it will reflect back certain colors, so they'll appear to be a certain color. So you see those tubes that had a specific gas in them, they would glow a specific color. So if you create a compound of metal and that chemical, it's going to glow a certain color. So the actual transfer of energy, so you have the chemical in the gunpowder and the heat from the fuse that you initially light. It causes the kinetic energy, which is the movement, the launch, the sound, which is the initial big bang you hear, and the heat. So that heat, it lights the next fuse, and that next fuse goes the chemical energy in the burst charge, which causes the big explosion. And so that explosion creates kinetic energy for the stars, as well as another sound, so that's a second boom. And then you also a ton of heat, as we just learned about, and that's what 1,000 degrees.
The actual stars.
So that heat goes into the stars, and those stars transfer because of the way that electrons deal with heat.
Energy, so the heat gives the
that
electrons
heat
energy,
transfers into
and when they release
light
it,
energy.
It turns into light, and light is what we see.
Also will sometimes, depending on the firework, transfer into kinetic energy as well. So obviously, fireworks are pretty complex in terms of their transfer of energy and the way that they organize things and deal with it. So they have a ton of stored energy with a little bit of heat, which causes this big chain reaction and this fantastic display that we're also used to seeing on those big holidays like Canada Day and New Year's Eve and all that stuff. So I hope you know a little bit more about the physics of fireworks and are interested in them. Have a good day.